morning, colleagues.
Morning. Morning.
My problem is based on the expanding balloon. Okay? Blowing up a balloon. Good. I'm just going to read a scenario and then I'll move on. Say you're filling up a swimming pool and you know how fast water is coming out of your hose. And you want to calculate how fast the water level in the pool is rising. You know one rate, that is how fast the water is being poured in, and you want to determine another rate. How fast the water level is rising. These rates are called related rates because one depends on another. The faster the water is poured in, the faster the water level will rise. In a typical related problem, the rate or rates you're given are unchanging, but the rates you have to figure out is changing with time. Now, here is about balloon problem. For example, say you're blowing up a balloon at a rate of 300 cubic centimeter per second. When the balloon's radius is 3 cm, how fast the radius is increasing? Good. Now let's just draw a little sketch of our balloon. Okay. And we need it, how fast the rate is increasing at 3 cm. Good. Now, first of all, we add the variable r because it will be changing. Yes. Now we're going to list all the rates to determine list all the given rates and the rate you're asked to determine as a derivative with respect to time. So we know dv, dp, dt is equal to 300 cubic cm per minute. Good. Now you have to figure out how fast the radius is changing. So we will need dr over dt. This is what we need. Good. Now, as we all know, the volume of a sphere is V is equal to 4 over 3 pi r cubed. Good. Now we differentiate our formula with respect to t. dv dt is equal to differentiating. So we will have 4 over 3 pi r 3 minus 1. Oh, yeah, sorry. Remember the 3 multiplying. So it's 3 r 3 minus 1. Good. So there we have our final answer. 3 cancels out with 3. 4 pi r squared. Oh, sorry. Yes, so as we know in implicit differentiation, this will be dr dt. Sorry. Good. Now, after differentiating, okay, we plug in our values, our known values, which when r is equal to 3 and we have dv dt is equal to 300 we will get, therefore, 300 is equal to, there's 4, 5, R, which is 3, square, dr, dt. Good. Now, little calculation. 300 is equal to 9 4s 36 5 dr dt. Good. Now we need dr dt, as I said earlier. So we divide by 36 5, both sides. 36 5. Let me just continue here. So 300 divided by 36 5 will give you dr dt, which is 2.65 cm per minute. Now, so the radius is increasing at a rate of 2.65 cm per minute when the radius is 3 cm. Yeah. So now, if you were to plug in 5 cm into the same formula used, you would have got an answer of 0.95, which this fact proves that the bigger the balloon gets, the slower it grows.